Welcome to Tools Tuesday here on Answer Everywhere. Today we're looking at the source code for the program GNU Sed. Sed is it calls itself a stream editor, and you may know it as the Unix utility that lets you do regular expressions editing from the command line. I use it regularly. Hopefully you use it regularly too. It's a great little utility. And yeah, so we're going to peek at what makes it go. If you haven't used Sed, then just to give a quick example of what it's up to, you can use it to operate on files, like doing kind of like a fancy find and replace. But you can also pipe things into it, which is a common usage. So you could pipe like echo hi, which of course just echoes hi. If you pipe it into Sed, you can give it this command, and a common one is replace, which is probably just called substitute in the source code, I would assume. And you can say substitute for hi, substitute by. And I have to terminate my sed command, and you get by. And you see this this syntax pop up in just like programmers speak a lot. So like if somebody sends an email, they might make a mistake or a typo, and they might send a follow-up that says like S typo, correct word or whatever. So I'm not sure if this syntax originated with Sed, but it's certainly part of programmer culture. I pulled it up in Wikipedia. Wikipedia tells me Sed was developed from 1973 to 1974. So by Lee McMahon. I don't know Lee McMahon, but I do know Bell Labs. So this is a classic utility, probably part of the original Unix, I would guess. Oh, first appearing in version 7 Unix. It's one of the early Unix commands built for command line processing of data files. Yeah. Similar commands, and I guess it mentions these are grep and awk. I'm not sure if it mentions awk, but that's that. So I open up the Sed documentation and it says, you must read these docs to understand the Sed world. And my eye fell upon, just happened to fall upon using Sed to create a book index, which unfortunately 404. So I don't know how to use Sed to create a book index, but I do have handy one-liners for Sed. These are, I'm not sure if I'm always pulling up the same file or if there are a lot of different Sed one-liner websites. But a lot of these are really useful. So you can do things like print the last 10 lines of a file, but you'd probably rather use tail for something like that. And you can print a line, only the lines that match regular expressions, similar to grep. You can print the line before the regular expression. And let's see what else you can do. You can delete, here's an example, delete duplicate consecutive lines from a file. That's the sort of thing I use Sed for. There might be some other way to do it. I guess unique, if you have like a sorted file, and you can do all sorts of things. Basically anything you can think of throwing a regex at, you can do with Sed. And yeah, so just for fun, I have ChatGPT. I'll ask it, how do I use Sed? I'll call it the Sed utility, just in case it gets confused, to generate a book index. Is that what it told me I could do? To create a book index. Let's use that language. To create a book index. Is ChatGPT going to respond? Okay. All right. It's not, its primary purpose is not creating book indices. That's fine. So it's going to print out a command. This will search for a line starting with a hash character. Okay, so I guess it's looking for markdown headers and print them to the console. And then it's saying you can use sed to format the index, like writing it alphabetically. Okay, yeah. So let's ask it if it will create a sed script for indexing all occurrences. How do you spell occurrences? Of Romeo. And Romeo and Juliet. Let's just see if this is something it's able to do. All right, so it's going to at least try. Is it going to print the line though? Okay. All right, while it's telling me what's going on, why would I want to, okay. Let's just run this command. I downloaded Romeo and Juliet, and let's see if this works. I think it actually is called Romeo and Juliet.text. Then let's cat whatever the index is, and let's see what it did. Okay. So we've got all of the occurrences of Romeo, basically like grep. I don't know if I would call this an index, but that's good enough, ChatGPT. Thank you. Thank you for your help. Okay, so let's actually look at the source code. And today I've opened up the Git web installation. Usually I look at the GitHub mirrors because the interface seemed a little bit nicer on GitHub. But now I'm realizing a couple of things. One is that Git web gives me file size, which can be useful. I don't need permission. I don't need to know the permissions, but that's fine. What I don't know is if I open this file, it should take me to the tree, hopefully. I'm not positive that's the case. This is a blob. Okay, that seems right. But it also has the ability to grep all the files and I assume make it into a regular expression. So I'm thinking that since I probably have, this probably has better search than GitHub. This is essentially what I'm thinking. So let's give this a try. All right, we're on the Sed source code, and we've got a README and a README hacking. The hacking might be interesting, but we'll not look at it. Basic devs.h, probably interesting. Build aux is presumably extra build configuration. As Romeo. Thank you. Did I make a mistake, Evan? I may have made a mistake. I'm not sure if you're correcting me or just giving an example of Sed use. All right. Doc will ignore. Lib might be useful. Sed will definitely be useful. M4 is macro preprocessor or macro processing stuff. Po is internationalization. And we'll look at the test suite. What have I done? Did this not open what I thought? No, okay. It did open correctly, but maybe in the reverse order. So where's this? This is lib. Okay. This is the sed directory. And here's the test suite. So let's look at the test suite. And we seem to have a lot of tests. The tests seem to be shell scripts for the most part. Let's look at title case. Maybe this will tell us how to make title case using Sed, which I actually don't know how to do. Test case insensitive matching for title case in similarly odd cars. Okay. And this does, yeah, this is a bash script. Oh yeah, in my GPT prompt there was a typo. Oh, okay. Well, yeah, too bad. Do I ever use LSP or C tags for source code review? I do. So that's a good question. I think I'm going to do maybe the next theme Thursday is what I planned. I've been thinking of looking through, looking at the code of various LSP implementations for like various, programming languages. Like, I forget what the C one is, super famous, and those sorts of things. I haven't used C tags for a while. When I was at Google, they had an internal system that was great. That I don't know if it was based on LSP, but I think probably they might change over to LSP. I don't know. When I used C tags back in the day, I didn't have an amazing experience. So I try to use LSP. The support isn't always great in all of the languages, or at least I've never been able to configure Emacs to have great support for some of the languages I've used. And so in practice, I do a lot of stuff without LSP. But LSP is great, and I would like to spend some time looking at it. If you have if you have an LSP implementation for a language that you think is really great, let me know, and I'm happy to include that. Yeah, and I've considered, like, I guess following on that rambly bit. I've considered using something like maybe I think SourceGraph does it. Something that's basically like a web front end powered by something like LSP that will allow me to click on identifiers and go to where I want to go. I haven't done that yet. That adds a lot of complexity. So I want to really know what I'm doing before I do that. And there's a lot you can get just by peeking at the source code. So that's the deal. At Google, of course, they have. I'm trying to remember what the public version is called, but I think the public version is just called Code Search. So for some of the Google repos, you can use the Code Search interface. I'm not sure if it's literally the same code. In some cases, they might have like ported something. Like I think Chromium might use like a custom Code Searchy thing, but that's kind of the standard. The Rust, yeah, I'll look at Rust's LSP. That would be great. I haven't looked at. Okay, cool. If you think SourceGraph is cool, then I'll take a closer look. I don't think it should be too hard to get up and running, but presumably it needs to like chomp on whatever repo I'm looking at ahead of time and like load it into memory and make trigram searches or whatever these things do. That's a great idea. Thank you, Evan. All right, so we're looking at this title case test. It's a bash script, and I'm not sure what require L is. Require L ISO. Okay, something about ISO locales. And we're just going to print the version, assign some variables. These look like maybe ASCII codes. And then we're going to have this printf command. And somewhere we should call sed, right? Yeah. Okay, so here's the sed to call. And we're going to call -r-n-f prog in, and then it's going to go out and or fail one. So for each character, A, B, C, and D, we're good. Oh, this is sigma, maybe. Is this the character sigma? And what is stigma? I don't know. And then what is... I'm not sure what prog does, but I don't think we've defined prog. Oh, here we have. Okay, so the prog is this program. And I don't know everything that's going on. This is kind of like the slash is like the beginner of a Sed program. I forget what the empty parentheses does, or what //1 does, and then we've got this car stuff. Okay, so we've got lots of tests. Tests are good. They seem to be doing it with Bash, which seems pretty like a reasonable way to test a shell program, a Bash program. Okay, cool. All right, what else we got? This is disorienting me because I'm used to looking up here for what directory we're in, but this is just the tree. I think we're in the test suite directory. Okay, let's get rid of this. Here's lib. Lib has local mk and git ignore. So is that really all that's here? Okay, so there doesn't seem to be much in lib. I guess I'm curious why what git ignore is doing. This seems to be ignoring a bunch of C files. Okay. And then here is the root directory. And it's a small number of files. Let's see, what's over here? Basic defs. Let's look at basic defs first. So let's just define basic defs. We're going to include some stuff, cars, I guess maybe wide cars, locales, wide C-type standard Boolean. We're going to include get text, which makes sense. xalloc and idx. We're going to define memdump, some basic definitions to avoid undue promulgating of ugliness. All right, I don't know what not importing these would cause ugliness, but maybe these are frequently used. Some allocator stuff, string equality, which is going to be basically inline. No, it's going to call it the string compare. Oh, it's just calling whether string compare returns a 0. So it's just a convenience method, I would guess. Similarly for string, maybe it's just here to make the code more readable. Got max path, and we're special casing for GNU herd because it doesn't define max path. All right, and handle misdesigned ctype.h macros. Some C-type macros are valid only for character codes that is ASCII says are ASCII. Okay. Okay, so some macros, I guess, check whether something is ASCII before they apply, maybe. So all C-type uses should be through macros like isPrint if standard C headers is defined. All right, so that's some fiddly bits about supporting different platforms. SGI is maybe Silicon Graphics. Okay, all right, what else? And then some print stuff, is alpha, is digit, that sort of thing, and initialize main. Okay, so not much in basic defs. And then so we're down to the C files, which is not surprising. I imagine that this was going to be not a lot going on. So presumably everything's in sed.h, sed.c, and regexp. We've also got execute. I guess let's open up execute just for completion. And let's update, open the utils and swap the utils header and C. And I guess I don't really feel a need to look at debug. All right, so here we are in the sed header file. And includes look reasonable. Nothing's really popping out as surprising. So we have a struct vector that's used to describe a compiled sed program. So I guess you could compile sed programs. I've never done it, but maybe that's an efficiency optimization if you're going to run the same program repeatedly. And it's a struct that has a sed command or a pointer to a sed command, which is a dynamically allocated array. A v allocated is the number of slots allocated, and v length, the number of slots in use. Then we have, output structure. This structure tracks files used by sed so that they may all be closed cleanly at normal program termination. All right, so we're going to just track anytime, I guess, sed touches a file, they get thrown in this in an output struct so that we can close them at normal program termination. I guess they make no promises if you abnormally close your program, like if you pull your power cord out while it's running. A flag is kept that tells if a missing new line was encountered so that it is added to the next line and the two lines are not concatenated. Okay, so some new line stuff. And so what is the output? It's got the name, presumably, of the file, whether it's missing a new line, a file pointer, and it's got a struct output link. And since this is a recursive reference to the same struct, this is presumably a linked list. So like, I guess, pointing to the next, possibly the previous output file. And I suppose we'll see maybe, since this is a relatively small amount of code, we may see somewhere that something's going to walk like a linked list of outputs and close everything. Let me just verify that it's not a gigantic single file. Okay. We've got a text buffer, which just has a pointer to a text, like a car star pointer, which is conceptually a text array. And it's got its length, which is even more conceptually makes it an array. And we've got a regx struct, okay, which has a pattern, some flags, size, abbreviated as SZ. DFA, I'm not sure. Let's look up DFA. But we're also going to check whether it's beginning line or ending line. And then a car, which is RE at 1, which is different from the regxt pattern. I'm not sure what this car is doing. I'm not even sure what RE is. We have RE at the index 1. Maybe we can dig into that, but I was going to also look up what's DFA. DFA Milk, Department of Finance and Administration. I'm assuming this is either Unixy or C something, equivalent of DFA and NFA. So yeah, we've got stuff about regular languages, deterministic finite state automata. So a regular language is like is a language where you have some automaton that can essentially, I guess, act as an oracle. You can feed it a string and it will tell you whether or not that string is part of the language. I think that's what a regular language is, right? Let's double check this. So it's recognized by some automaton. And so I guess it's not surprising that we have this deterministic finite state automata. A formal language that can be defined by a regular expression. Yeah. All right. Alternatively, a regular language can be defined as a language recognized by a finite automaton. Okay. And Kleene theorem is what gives us the equivalence of regular expressions and finite automata. And you know what? I was always under the impression that regular expressions were called regular expressions because they are used in regular languages. But Wikipedia is kind of making it sound a bit like those two things were at least originally separate, and then their equivalence is due to a theorem. Wait, I don't want a formal language. I'm just curious now about which came first. Okay, so sequence of characters that's, okay. Regular expressions originated in 1951 with Kleene when he was describing regular languages. Yeah, okay, so it's due to their relationship with regular languages, and they're the things that are recognizable by a finite automaton. Okay, cool. So we've got some reference to what seems to be a finite automaton. We've got a read command, which is going to take a file name as a character string and whether to append as a Boolean. Some replacement types. This is a little bit interesting and unexpected to me, but Replace as is, uppercase, lowercase, uppercase first, lowercase first. I don't know if uppercase first is like sentence case. And we've got replacement modifiers. And the modifiers are replace uppercase first or replace lowercase first. So we're going to OR these together. And they are 4 and 8. So 4 and 8 are both powers of 2. So they all have 1 bit set. So when we OR them together, we get something with 2 bit set. I don't know what that means, but that's that seems to be a true thing. And we're going to define some other. Oh, okay. And these are given to aid in debugging. We're also going to define replace uppercase, uppercase, replace various combinations. All right. We've got text types. It can be a text buffer, a text replacement, or a text regex. I'm not sure. Should we consider a text replacement to be a replacement? I'm wondering if it's thinking of the replacement as like a diff, maybe. It seems to be thinking of a replacement as like a piece of text rather than like a function or whatever. Posixicity, some POSIX stuff. Adder state, maybe address. And we've got range inactive, range active, and range closed. So inactive means it's never been active. Active means we're between the first and second address, and range inactive, but the range has ended once. So I guess this is keeping track of, like, you have presumably a range of text. Like if you're looking at Romeo and Juliet, you're at like line 570 or whatever. And let's say that you are looking at the range that consists of the first 4 words in that line, then I guess Sed is keeping track of whether we've operated on that range yet. And if not, I suppose it's inactive. Then when we start operating on it, we label it as active, and then when we're done, we close it. And I guess that's perhaps for keeping track of context. So you can maybe do some context aware stuff. I don't know. And we've got more adder types, whether it's null, regex, num, mod. Address step is modulo. Okay. Mod is modulo. Whether it's a step is a step modulo or is last. A.adder regex is valid. Oh, okay. So given an address, you can look at its type to see, I suppose, whether it supports, like if you want to, this is kind of like, this looks a little bit like hacky type checking, right? So we've got this enum type, and we want to know whether we can call adder regex on it. And so normally that would be done by some kind of like type checking system, right? So you pass a thing in. If it implements the regex interface, then you can consider it a regex. But here we're just going to take the address, presumably is what A is, and if it has this flag set, then we can validly call regex. And Evan says it sounds like submatches to me when A plus matches AAA and A and quadruple A. Evan, are you talking about the address state or the address types, or something else? I'll wait for you to answer, but I think you're probably right about if you're referring to like the state. But let me know. So like regexes can do this thing like ranges. Yeah. I think you're right. That's a good point. So and there's also stuff like regexes also support things like ranges. Not ranges, but like groupings. And I'm not sure. I don't know a ton about regex implementations, But yeah, I think that there are some things that regexes I think don't always have to go in one pass, maybe. And for some stuff, you're not just like walking through the range once and doing something. You may have to like go back and check stuff or whatever. And I think that that's the sort of thing. It's like part of it's an automaton, right? So I think an automaton, a finite automaton, you can basically think of as a Turing machine. So the Turing machine might have to run its tape backwards a few times, go backwards too and check whether this thing happened. So I think it's support for that sort of stuff. And I think that's similar to what you're saying. But again, I don't, I'm just I'm just guessing. So, but yeah, I think you're probably right that this adder state, the range stuff, is probably for supporting features like submatches. Okay, so what else do we got? Address stuff, address number, address step, which I guess is like whether we're going to step one at a time or two at a time, and like a pointer to an address regex. And it has the address type. So, all right. But is this the full adder? So we've got a type and a number and a step. Yeah. Okay. And a regex. So that's what an adder is. It's this cluster of goodies that you can that you'll, I guess I'm going to assume that this is a really fundamental type to what it said is up to. We've got a replacement, which based on the name, is I assume this is going to be how you're going to encode what a replacement looks like, essentially like a diff. You've got a prefix, like a pointer to a prefix, essentially an array, a character array, a length, a subst ID, I suppose a substitute ID, which presumably is unique in the context of a run of sed, and a enum that gives you the replacement type, and a struct of a replacement next. Now, okay, so this is again a recursive call to replacement. I'm gonna guess that next here is gonna operate like a linked list again, similarly to whatever we were looking at before. Something that had next. Oh, it had link. That's more clearly a linked list. But what I don't see yet is like what does it have the replacement text? We've got the enum, an ID, and one array and a length. So if you're replacing foo and bar, I'm not sure what prefix refers to. Maybe it refers to the address of foo or the address right before foo. I'm not sure. Well, I guess we'll have to look at where replacement is used. Or maybe what I'm thinking of is subst. Subst is maybe substitution. We've got a regex, a replacement, a numb, which is presumably a number. Only substitute for match number, num, okay. You've got an output, a global, we've got global, print, eval, and max ID. And then if def lint, we've got a replacement buffer. So replacement buffer, I guess I expect to see. I don't know why it's only used if lint is defined. I don't know what happens if you don't have lint defined. All right, but what are global, print, eval, and max ID? They're unsigned. And global means, oh, okay. So this is just whether certain commands, I guess, were passed in, maybe. So whether G was passed in, like in sed, if you want to replace a word, typically it'll replace just the first occurrence of the word in a line. But if you wanted to replace all occurrences, then you like terminate a command with G. P, print. Okay, so print is going to print some stuff, and eval. So you can call sed with this eval argument, which I've done before, but I don't quite remember when or why I've done it. And then we've got a sed command, which is looking like it's going to be of major importance. So we've got two addresses, A1 and A2. Save space usually is null, right? And we've got the address state, and it says to see the enum above, which we have. Address bang, it's non-zero if the command is to be applied to non-matches. Okay, so bang, I'm guessing, means the exclamation mark, which is commonly called bang among coders. And if it's non-zero if the command is to be applied to non-matches. So this is like invert, I guess, the regex. So it's the same as applying, like logically, it's the same as applying the not operator, which is commonly depicted, or the syntax for the not operator is often exclamation mark. So I think that's what adder bang is up to. The actual command character, which is a single car, and I'm guessing it's character in the sense of like the substitute command is S. And then we've got auxiliary data for various commands, which is going to be a union. And the thing in the union is presumably going to be picked out by what command we're using. So for A, I, and C commands, we've got a text buff of command text. Right? So I guess if it's going to execute a command, it needs to know what the command is. For L, P, and Q commands, we've got an int arg. The empty curly braces B and T commands has a jump index. The R command has a read command struct. This is to be used for the hairy S command. It's going to as a pointer to a command subst. And I don't know what makes the S command hairy. Let's, just for the sake of argument, let's look at info sed, but let's look at it maybe in Emacs. Wait, what? Or maybe I want man. Oh, now. All these warnings. Let's try this one more. Let's try this one more time. There we go. All right. Here's the command synopsis. So, okay, 0 address commands, label, comment. So A is append, I is insert, Q is immediately quit the said script without processing anymore. R is append text from a file. R is append a line from a file. Okay, and so the curly braces just enclose commands, and I don't know what that means about the empty command. S is regex replacement, which says attempt to match regex p against the pattern source. I don't know what makes it hairy though. Okay, well, I'm not sure. Okay, and then we've got some other stuff like out F, out file, in file for different commands. And then this looks pretty fiddly. No return void bad prog. It has a pointer to Y. No return void bad prog, no translate. So these appear to be error stuff. Some stuff about normalizing text, compile strings, check final program, rewind, read files, compile regex, which is going to take a struct buffer, star B, int flags, and int needed sub, and regex matching functions, and a bunch of other kind of like, we're in the header file, right? So these might be definitions of just function signatures that we're going to redeem in the C file. So let's take at least a quick look at the C file. I'm guessing that the next interesting thing might be the regex header. Bunch of if and end if stuff that kind of makes it hard to see for sure like what's important. Okay, if the environment variable calls the set, use its value for the baseline setting of L command outline length. Okay. So we've got this big while loop and a switch statement inside. That's going to get options. And maybe this is just the command line parsing. So let's look for S, command line S, case E, separate. So if you pass in S, says separate files is true. So maybe this is passing in, yeah, so this is like dash S, passing in the S command line argument as opposed to the S sed command. Okay, so if not the program, we'll do some error stuff, including exit bad usage and some other error-y stuff. Okay, so that's the sed.c file. regxp.c. Did we have regxp.h or does it just go just straight to the C file? Yep, just the C file. Cool. Let's look at it then. So presumably we're importing some other regex library. No? So we've got C-type limit string, standard ckdint, standard IO, standard lib, and xalloc. And we can compile a regex. And yeah, all right. So what are we going to do? We've got this syntax thing. It's an int. And we're just checking, I guess, which regex expression syntax we're using. And we're going to switch on posixicity. And this seems to be like more kind of figuring out what syntax we're using. And more case analysis, error handling. We'll check if needed sub. Just to be sure, I mark this as not posically correct behavior. If needed sub and new regex pattern .re end sub is less than needed sub -1, and posixicity is posixly extended, I guess this will error with bad program. So somewhere we actually do work, right? DFA, okay. Oh, I see. So we're going to get, we're going to make this integer, DFA options. And it's going to be set equal to whether or not, depending on whether the buffer delimiter is new line or not, the DFA ops is either going to be 0 or DFA end of line null. So I guess that's telling the DFA that a line is terminated by a null character, maybe. All right, and then new regex, the DFA is going to be, we're going to, I guess, alloc some space for it. We'll set the DFA syntax to whatever we did with all of the code up here. Where's that syntax set? Okay. And then DFA comp. So we're going to compile the DFA, and we're going to pass it in the new regex RE, which is presumably the regular expression itself, maybe as a string or a character array. The new regex size, the new regex DFA, which maybe DFA comp will populate, and 1. And this is maybe, this looks like the struct that we looked at in the other file. So new regex is, of course, what is passed in. It's a struct it's the regex struct that's passed in. Okay. And then we check if the size is 1. And if it's the matcher for the beginning of line, we just set regex begin line is true. And if it's the matcher for the end of the line, we set end line is true. And that is presumably just an optimization so that we don't have to keep computing whether the size is 1 and doing this thing. Okay. So here's the compile regex, which we called, wait a minute. Here's compile. We were looking at compile regex 1. Here's compile regex not 1, which is instead of taking a regex struct, compile regex not 1 is going to take a buffer, a struct buffer star b, some flags and needed sub, and it's going to create a new regex and presumably call regex 1. Yeah, okay. Here's the regex matching stuff. It's going to take a regex, a buffer length, buffer start offset, RE registers, which is a reg array, which is called reg array, which is, I suppose, a array of regexes, and reg size, which I will guess is the size of the regex array. All right, and we'll keep track of the last regex, I guess. Static struct regex star regex last. All right, keep track of the last. All right, last is in like most recent, as opposed to last is in final. So we'll keep track of the most recent regex matched, it looks like. And if regex, I guess, is null, because it's a pointer, then we're going to set regex to regex last, which we just created and might be not have any data. I guess it might be the null pointer, right? Okay, and so if regex last is not good, so we don't have a regex or regex last, then we have a bad program. All right. Else regex last is just going to be equal to regex. Reg off t is going to be buff length. We're going to create a thing of type reg off type, and it's going to be called, the variable is going to be called buff lang reg off. If ckd add buff length reg off, blah, 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 we're going to panic. So this is some error condition. If regex pattern no sub and reg size, I don't know what no sub means. And reg size, I guess, is non-zero, is what this is checking. Recompiling an existing regex, free the previously allocated structures. Okay. So for some reason, this is interpreted as we need to recompile an existing regex. And so we'll free some stuff. We'll set, I guess we'll mark that the reg expression has been allocated or reallocated. Okay, so here's optimized handling for begin and end line. We're going to get the offset, check whether it's end line. If so, do some stuff, check for new lines, etc. Some offset optimizations. And yeah, okay. Do we do anything interesting? We've got Memker, big line anchor starting in the middle of the search buffer. All previous optimizations didn't work. Search for the next new line delimiter character in the buffer and start from there if found. So we're going to call Memker with buff plus the offset with the buffer delimiter and the buff length minus the offset. So that's like the end. And that's going to give us a constant car p star p. What is Memker? Locate character in block of memory. All right. So we're just going to search through the memory to find a character. I didn't know that was a function call that you could do. All right, we're going to check whether the thing that we got from Memker is null. If so, we're going to return 0, which is usually a success condition. So does 0 mean success, that we successfully did nothing? Otherwise, we're going to set offset to p minus buff plus 1. We're going to check if reg size is non-zero. Reg size is an int, right? Yeah. And if so, we'll do some stuff. Look, xn malloc. If not, reg array started. So if we haven't maybe started, then we'll alloc some stuff, I guess, xn malloc. and set the number of regs to 1. And then we're going to set the start and end. For both the start and end, we're going to index into it and set the 0 index to offset. So what was reg array again? Reg array was a struct that was RE registers. Let's see if I don't remember if that was a struct we looked at. Is it registers? Yeah. Am I in the right file? All right, can I grep? Let's grep. Okay, execute. Maybe? Let's check execute, let's see. No, that's just a function that takes RE registers. Yeah, I'm not sure where this RE register stuff came from. Declare RE registers. Sed.h. Shouldn't it be in sed.h? Maybe it's in something we import. I don't know. Okay. All right, well, whatever that is, we're going to do some stuff with it. All right, if the buffer delimiter is not a new line character, we cannot use new line anchor flag of regex. So do it line by line and add offset value to the results. Okay, so if we're not using new line to I guess to section it into different buffers, we do it line by line. So if we're going to AND the reg new line with the flags, and the delimiter is not the new line character, we're going to get the beginning and end, do some computations with the offset. Then we're going to have this for loop, this eternal for loop. We're going to get the end by calling Memker. And if the end is null, we'll set it to the buff plus the buffer length. Is that what, maybe Memker returns null if it's at the end, or if it doesn't find it, and we're just assuming that it's there. I don't know. Then we're going to call RE search, like regular expression search, with the pattern, the begin, end, etc. And get a return value. If return is bigger than 1, we'll do some stuff. Otherwise, we'll do some other stuff. Okay. Otherwise, I'm not sure what we're otherwising it here. Okay. So I guess we do have new line, or we don't. This flag isn't set. In that case, we'll call regular expression search with the pattern, the buffer, the buff length, the buff start offset, and some other stuff. And they're going to return whether ret is bigger than -1. So I guess 0 is a success condition, and this is just checking that the return value is positive. No, wait. We're returning an int, and this is a bool. And so presumably this returns negative. Maybe RE search returns negative if it's not found. So this is returning whether it's found. And the return value, I think, is an int. Yeah. So an int essentially, maybe coerced, you would call it, into a Boolean, will return, we want this to be true, right? That should be 1 as opposed to 0. So maybe 0 is false up here. But I missed this part, but somehow we've got this superset stuff. We can have a DFA superset and a DFA exec. So it seems like the real work is being done by the DFA library, which I guess was imported in the header. All right. All right. So, and then we can release the regex. Okay. Cool. And then execute. This is presumably responsible for executing the commands. Once we've marshaled everything appropriately, we know what the regexes are, and we've populated our whatchamacallits, the various structs. Okay. DFA slop, the number of extra bytes that must be allocated and usable beyond the declared end of each line buffer that may be passed to match regex. This is imposed by its use of DFA exec. So do we import, we're importing SE Linux. I didn't know Sed had SE Linux support. But do we import the DFA stuff here as well? No, okay. Okay, so we've got a line. So Sed operates a line at a time. And for a line, we're going to have a pointer to the line allocated by malloc, pointer to non-consumed part of the text, okay, which we're calling active. The length of the text, allocated space for active, and chomped, whether it's been chomped, was a trailing new line dropped. I guess sometimes, I don't know what this is, but you can ask Sed to delete new lines. So if you have a file with let's say one person's name per line, and you want to make it like a comma delimited, a long comma delimited string that's one line, you can ask Sed to delete new lines. I'm wondering if chomped is recording whether Sed has deleted new lines, because it sounds like maybe they use new lines to determine like the boundaries of buffers or something. So maybe they need to keep track of that to know how to handle situations like that. And then MB state. MB, I'm not sure, but some sort of state. All right, size of line. Okay, we've got a queue, an append queue, a queue of text to write out at the end of a cycle, filled by the A, R, and R commands. And it's got a file name, text length. So presumably this is like a message, right? A message to write out. So that's like presumably the message part of it. How long is the message? Because we're in C, and strings are crazy. And append queue star next, and free. Is this a queue? I guess it is a queue, right? We can consider a linked list to be a queue. Yeah, sure. Okay. State information for the input stream. Struct. So here's input, and it's got stuff for the input stream. The list of yet to be opened files. It is invalid for file list to be null. When file list is null, we are currently processing the last file. It is invalid for file list to be null. But when it is null, we are currently processing the last value. What? I'm guessing I'm supposed to be reading this star as significant. So file list with no stars can't be null, but file list with one star can be null. And that means we're at the last file, and file list is actually a car star star. So I'm guessing, I don't know if star file list means star star file list or what, but some fiddly stuff. You have to pay attention when you're programming, whether you're dealing with a pointer or a pointer to a pointer or whatever. All right, so we're going to count the number of files we've failed to open. All right. The input line number, whether to reset at the next file. True if we'll reset line numbers and addresses before starting to process the next file. Makes sense. If you have a bunch of files, you probably want them numbered separately in general. Maybe sometimes you don't. There's a function to read one line. It's going to take an input star, and right. I guess this is like a function type, right? And it's got a bool. Read always fail is recommended. If FP is null, read function better not be one which uses a function pointer. All right. We've got an output file name and input file name. The owner, this is like, I assume this is like Unix file stat. Owner and mode to be set just before closing the file. And we've got a file pointer. If null, none of the following are valid. No buffering. None of which following? No buffering? I don't know. Okay. Have we bool replace? Have we done any replacements lately? This is used by the T command. I don't know what lately means in this context. My current output file lines, an accumulator, an input line used to accumulate the result of the S and E commands, which is a struct line. An input file that's been stored by later use by the program. Okay. Some buffers. So accumulators, buffers, hold, and append queue, which has a head and a tail. Prepare for LV's length by len, making some attempt at keeping realloc calls under control by padding for future growth. Okay, so this is like resize line. And presumably it's just going to alloc some stuff, right? So here's alloc. And we're going to move some memory in alloc. Yeah, okay. So we're growing something. Here's string append. Append length bytes from string to the end, right? And we've got more alloc-y stuff. Append modified. And presumably this is more, yeah, mem copy, alloc, that sort of thing. These are like string copying, like string append methods, it seems like. Line init. Initialize a struct line buffer. Copy multi-byte state from state if not null. Okay. So this is more memory stuff. If you've you have to do a bunch of this stuff if you work. There are some C textbooks where like the first many chapters are like, you know, do all of these string things. And then eventually you get to something like C++ and you don't have to implement this stuff anymore. All right, so more line copy. I mean, this is all, Sed is doing this all, not because it doesn't have access to better string libraries, but because it's super efficient and it's customized to their stuff. So I'm not trying to say that Sed is doing this because it predates C++ or anything like that. I'm just saying, like, as an ordinary programmer, you usually wouldn't be working this low level unless you're working on something super optimized, like maybe for an embedded platform or for a platform that doesn't have a lot of standard library support or whatever. But I'm just kind of skipping over it because that level of detail isn't really necessary to figure out more in a general way what Sed is up to. We can exchange some lines. We have a dummy function to simplify read pattern space. Read always fail will return false. Okay. Read file line, output line. We can we modify, do various things with append queues, like release them. We've got a get backup file name. Compute the name of the backup file for in-place editing. Huh. I don't think I knew about backup files. We get the length of the backup file, track on what's after the last asterisk. All right. Open next file. Oh, you know what? I think this is for like, maybe the backup file is for if you, when you call in place, right? So if you call sed with the -i command line argument, then it will in place edit your files. And if that command fails, you don't want some of your files to be edited and some not, or like your file to be edited halfway. So in that sense, it absolutely makes sense that it would have that it would do things in like a backup file, or at least make a backup of the original before it starts manipulating stuff. We've got open next file and close down. Read pattern space. What's read pattern space? Read in the next line of input and store it in the pattern space. Return 0 if there's nothing left to input. And we've got last file with data P. Match an address P. Return non-zero if the current line matches the address pointed to by adder. We've got these adder things. And we want to return non-zero if the current line matches the address. Does that mean we're going to look at the text in the address? So let's take a look, I guess. Match an address P is going to take a struct, a pointer to an adder, and a pointer to input. And depending on the address type, if the adder is null, then everything matches. If the adder is a regex, then we're going to call match regex on the adder regex. With the active line, give it the line length 0, and I'm not sure what null here is, but so this does seem like it's not, you know, it sounds like maybe it's not so much the address pointed to, but the regex contained in the address. Adder is num mod, so this is the modulo thing, and we're going to return. Let's see, we're adding, so two conditions, whether the line number is bigger than the address number, the adder number, and whether the input line number minus the adder number modulo adder step is 0. I don't know why, what this would be for. So we're checking whether the line number minus the adder number has no remainder modulo the address step. So I guess if the adder is, we're in some sense like looping around. Although I don't know really what adder is num mod is used for, so I don't have a sense of a good sense of why is this a thing that they designed and implemented. I don't know. So adder is step, or adder is step mod, adder is last, adder is num. Okay. Cool. We can match address P, which will return non-zero if the current address is valid for command. Okay, and so I guess we're going to peek into the adders. My guess is we're going to peek into the adder somehow and compare its contents with whatever is expected for command. So I'm going to do some switching. And what else? Let's look at adder is regx. Return true. Right? Let's take a closer look actually. All right, so if not command A1, then we return true. A1 I think was an adder. I think A1 and A2 were adders in the command struct. If we're in the active range, then we'll do some stuff. What if we're not in the active range? Where does this terminate? So here's the one brace. Is this the matching brace? Okay, this is telling me that the range set is range active. Check if the range is ending. Also handle adder is num, especially in this case. So if it's not active, for some reason we check adder is num. Oh, we're looking at command A2 now. Okay, so otherwise I guess we check whether we set something to range closed. Other addresses are treated as usual. If match an address P command A2 input, then we're going to set the range state to range closed. All right, I'm not sure, but let's look at the matching the matching case. Oh no, if range state is not range active, and if we get down here, we're starting a new range. All right, so if range state is not range active, then we're going to check whether there's a command A2. If not, we'll turn match an address P command A1 at input. Otherwise, there is an A2. There is an A2, and we'll do some stuff. Find if we are going to activate a range. Handle adder is num, especially. It represent an absolute state. It should not be computed like regexes. So if it's isNum, then we'll do some stuff like check whether the range is closed. Otherwise, we're going to check whether match and address P command A1 input. And if it doesn't, then we'll return false. This is a bool, right? Why don't we just return the value of this thing? I don't know. Or, right. So if this returns true, then we're going to negate it and it'll return false. I'm not sure why you can't just return this thing. Maybe this gives you an int in, there's some reason why you can't, I don't know. Okay. And so if we're here, then we're going to start a new range. We're going to set the range to active. And we're going to switch on command A2, address type. And if it's regex, we're always return true. If it's num, it's the same handling as below, but always include at least one line. All right. We'll check some stuff, like some bounds checking. And if so, we're going to set the range to closed. And then we're going to return whether the line number is less than or equal to A2 address number or match and address P command 1 input. Okay. All right, so we have a do list. What's a do list? It's going to take a line length. Unsigned car P, line active, output missing line. We're going to decrement length in increment P. Got some locale stuff. What is do list doing? Bunch of cases. This, I guess, is new line. I don't remember what B is. T is probably tab. R might be carriage return. B might be like page break. I don't know. There's like a, let's see, what are these called? Non-printing. I think these are ASCII characters. Isn't that what I want? I don't know. This is what I want. Something like this. Okay. Yeah. B is backspace. A is bell. V is vertical tab, form feed, and carriage return. I think that's what's going on here. So do we have any bells? Yeah. Okay. Not STDC. We'll assume ASCII. And if we see any of these things, we're going to break. I guess break means leave this for loop. Somewhere we had like a large for loop. We'll leave it. Otherwise, we're going to, I guess, get a character out of the buff. Out of the output buff. Presumably somehow out of the input or whatever. Oh, we're looking at star P. Okay. And star P is, we're going to cast line active to an unsigned car star. So we're just iterating, I guess, over this line active, I guess, imagining it as text, a character array. And we're building up, presumably, an output buffer. And we're going to set, I guess, the next line of output to the input if it's printable. And we're going to check whether it's equal to // And if so, we're going to set it to, we're going to do this thing, set it to // Although I'm not sure if this is equal, why does this not work here? Okay. So if star P is // then we're adding another // for some reason. Maybe to handle like escaping. Otherwise, what's otherwise? Okay. If we're not ASCII, I guess, or we're not printable, then we're going to mostly just break. Otherwise, we're going to do whatever this is. Which I don't know semantically what that's supposed to be doing. And then some length stuff. Okay. Append replace is some implementation of append replace. Do substitution. This is presumably the S command essentially. So we've got some substitution sub, a start and end account. Again, true. I guess this keeps track of whether to run the substitution again. We've got some regular expression registers. We're going to line reset. The first part of the loop optimizes S, XXX, or like whatever. It's supposed to be like, I guess, whatever S is, whatever XXX is, when XXX is at the start and S XXX end line. So we have an optimization for when XXX is at the start. Is that different from the up caret? Because this is the end line reg expression matcher. I'm not sure. So if not match regx line active, blah, 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 we're going to return. All right. Why is this an optimization? So we're going to call out the regx, and then we've got some debug stuff. Is that the optimization? Or is it this whole thing? If sub replace and sub number is less than or equal to 1, if reg starts 0 and not sub global, we found a match to set the replaced flag. We'll say that we've replaced something. Update lines active and line alloc and all of this stuff and go to post substitution. How we get a go to? Cool. Otherwise, if regs end is 0 is equal to line length. So whatever the beginning of regs end is the same as the line length. We found a match, set the replaced flag. Okay, so I guess we found a match, but we're at the end. The replace is true. Line length reg start is line length is set to reg start at 0. I guess that's telling us to resume at the start or something, and then we're going to go to post subst. All right. I guess the optimization is we're just going to return. So when XX is at the start and S is okay. So we're just going to, the optimization is we're going to call match regx with the sub regx on the line active and the line length, the start, a reference to the regular expressions, I guess, and max ID plus 1. And if that matches, we just leave. Otherwise, we do this other rest of this algorithm. Okay. And then we've got this do. We're going to get some offsets, which is going to be the start. Matched is going to be end regs end 0 minus regs end start. Oh, I guess maybe start and end are the indices of the match. Perhaps that seems to be what matched implies. And if start is less than offset, so okay, copy stuff to the left of this match into the output string. All right, so we're going to string append some stuff with an accumulator. And if we're counting up to the end of the match, are we there yet? And even if we are there, there's another case we have to skip. Are we matching an empty string immediately following another match? This latter case avoids that B quadruple AC when passed through S and some other stuff gives XB XXCX instead of XB XCX. This behavior is unacceptable because it is not consistently applied. For example, B quadruple A gives XBX and not XBXX. If we're counting up to the nth match, are we there yet? And even if we are there, there's another case we have to skip. Are we matching an empty string immediately following another match? Huh. So this is something with 4 A's. Wait, 4, right? And a B and a C. And when passed through these things, somehow gives XBXXCX. That's 1, 2, 3, 4 instead of x, b, x, c, x, which is 3 x's. I'm not sure what this is saying, but some sort of regular expression, matchy stuff. So we're going to check whether things are matched with the offset and whatnot. And if we found a match, it's going to be, we're going to set replace to true. And we'll expand the replacement string into the output string. Yeah, okay. So we've replaced something. And now in the output, it's not going to be a copy of the input, obviously. We're going to take whatever we matched and put as replacement. And we do that by calling append replacement, which takes an accumulator, the replacement, and I guess the regular expressions. And so that will presumably just write the replacement text to the output file, and then again is equal to sub global. So if we set the global flag, then we're looping over the line. And if we set the global flag, then we're going to keep looking at the line until we found all of the matches. If we add this else, then whatever if was, if matched is bigger than 0 or count is 0, or offset is bigger than last end. Wait, what? All right, so else, the match was not replaced, copy the text until its end. If it was vacuous, skip over one character and add that character to the output. Okay, so if we didn't replace the match, then we are going to just copy stuff until we're done. And then we're going to do some looping, while again, and start is whatever less than or equal to line length, and match regular expression is returning stuff is the while condition for the do loop. Okay. And then we're going to copy stuff to the right of the last match into the output string, and we're going to exchange line and s accum. This can be much cheaper than copying accum active into line.next. Okay. So this is some like memory optimization for swapping some stuff. And then finish up by checking whether the count is less than the sub.num, in which case we return. Okay. All right. And then that's substitute. That's, I think, the typical, that's probably the most common use case for sed, other than maybe deleting things that match your regular expression. And then, so what else we have? We've got static void translate MB, which translates the global input line via trans. This function handles multi-byte case. Okay. Some debug stuff. And execute program. Execute the program vec on the current input line. Return exit status if caller should quit, -1 otherwise. So execute program is going to take a struct vector and input. And I guess it's going to compile the program. So the current command is vector v. The end command is vector. Okay, so it's just a vector. So we're getting the current is like a pointer to where we are in the vector, and the end is a pointer essentially to the end of the vector. And so while we're not at the end, we'll do some debug checking. Check whether things match, and match address p, I guess, takes a command. Maybe cur command input is not equal to cur command add or bang. So if we're not like inverting the matches, I guess, we're going to switch on current command, and that's going to be these things that we've seen before. Here's the open parenthesis. It's the same as B, in which case current command is going to be vec v plus current command x jump index. Continue. So I guess we're just moving to the next thing. What is B? Do I still have this open? Let's see if we can find substitute. All right. B, label. Branch to label. If label is omitted, branch to the end of script. Okay, so it's a branching thing. And so we're going to jump index, whatever the jump index is. Okay. So that's how they do branching. Right parenthesis, hash, and colon. These are executing labels and block ends. We just break. So we're just ignoring them. All right, cool. And let's look at case S. G. We do not have a really good choice for the third parameter. The problem is that hold space and the input file might as well have different states. Copying it from the hold space means that subsequent input might be read incorrectly, while keeping it as in pattern space means that commands operating on the moved buffer might consider a wrong character set. All right. So we're going to copy some stuff. Right? See if we can find case S. Yeah, okay. For case S, we're just going to call do substitution. So essentially, it's so complicated. It's complicated enough that its implementation is not just right in this switch statement. We're calling out to a function. But for other things, it looks like maybe the implementation is not so bad, and we just include it in line. All right. So this is a big switch statement that's going to execute commands. All right. We've got this function process files, which is going to apply the compiled script to all the named files. All right, cool. And I think that's mostly what I wanted to see. Let's check out what MBCS is. MB current max. Maybe something buffer. Return non-zero of CH as part of a multi-byte, a valid multi-byte sequence. Okay. So some sort of multi-byte stuff. Let's look at utils. It's very small. Things like close, flush, init buffer, size stuff. Cool, cool. Here's util C. We don't need to look at that. All right. So that was said. I don't think that I understand exactly what's going on, but a few things that I do think I understand. One is that a lot of the hard logic, all of the reg expression logic looks like it's essentially delegated to the finite state machine library. And maybe before I'll go, I'll take a quick look at just to see where that's located. And then, it's a small program. And now that we have a sense of how things are laid out, if you're running a Sed program and you need to debug it, you should be able to look at the source code and be like, well, I know there's this giant switch statement in execute, and maybe that's where things are, or maybe it's in one of the other files that we looked at. But you have a sense of how the Sed authors broke up the complexity that's in the Sed program and kind of distributed it in different places. So I'm going to look up GNU Sed DFA library. Lib.dfa.c. Is it in lib? Did I miss it? I think I bookmarked. Okay, so it's C Sed. Let's try this. Yeah. So I think we did look in lib, and there was like nothing here. Maybe it's in sedlib? No. dfa.h. Okay. Where do I find dfa.h? These don't look like the one that I want. The DFA pattern matcher. Where did GNU go? I'm not sure. We have a DFA scheduler. Maybe it's Should also be used by grep. That would make sense. I'm not sure. So wherever DFA is, I don't seem to. I guess I might as well check whether I have it. We can include it. I don't know. So DFA.h, it's somewhere, presumably part of the GNU software distribution. I don't know which repository. They've got like a billion repositories. But that seems to be where the magic is, if you're really looking to understand the internals of how these programs handle regular expressions, or maybe if you're just curious about how to optimize a regular expression library, that would probably be a good place to look. And that's all for me. Thanks for watching.